This is Hannes Lowette. He's a developer, a coach, and a father of three. But the most important part that I want to tell you is that he's also a musician who builds guitars, which is pretty cool. And you can also find him on stage with Dylan Beatty and the Line Breakers. So that's the cool part about him. Now, about what he does and what it's, exactly. Superstar over here. If you want to read more about what Hannes does, you can read it on his profile on the website. So I'm not going to talk much about that. Just want to let you know how the questioning is happening in this stage. So if you have any questions during or at the end of the session, please type them in Pine, where I will be able to see them and pass them on to Hannes at the end of the session. Now, without any more delays, let's hear Stop Punching Yourself in the Face.
Thank you, Thea. I'm Hannes, and I wrote this talk because after being in the software development industry for over 15 years, there was some stuff that was getting on my nerve. And that's the stuff that I want to talk to you about today. Now, to get to the core of what we do, this is it. We deliver value. Value to a business, software that helps them succeed. That is the reason that you're all here, and that's the reason that our jobs exist. Now, let me tell you about a creature, the magpie. I don't know how it is in Lithuania, but in most of Europe, the myth goes that this is a bird that steals shiny things. It's black and white, it has a pretty long tail, it grows up to 45 centimeters large, has a wingspan of about 60 centimeters. They're omnivores, they eat pretty much anything, and they're pretty smart. And they're attracted to shiny things. Now let me introduce you to another creature, is the software developer, and you will see some similarities. They don't have wings, but they could also be black or white or whatever. They don't have any tails. They grow up to about 2 meters 20. No wings. They also eat everything. They're also pretty smart. And they're also attracted to shiny things. In this case being frameworks, tools, libraries like shiny new stuff. Stuff that we want to use. Now, the question you have to ask yourself, is that surprising that we are attracted to shiny things? Because in the software world, things change all the time. We're still a very, very young profession. And we're still inventing the way to do things properly. And technology is constantly evolving. And knowing this, you all got into this profession regardless. So it means that you're also like this constant pace of change. And this is very contrary to what Thea just mentioned. I happen to do some carpentry and some guitar building. And in woodworking and even in guitar building, there are set ways to do things. We have already found out how you can properly work with wood without splitting it, stuff like that. But in our industry, we don't have that surefire recipe for success yet, and our education is also limited. So this is something that we have to deal with, and we try to find solutions, and that draws us to these shiny things. Now, if you look at the state of software education in general, it's also not really that great. If we compare it to building a house, if you were in college, you would have a class that would teach you how to lay bricks, and then another class that would teach you how to do flooring, and a class about the theory behind roof construction, and you would maybe get some design class where you would learn to do electrical wiring and maybe some piping. And once you've had those 5 classes, they send you into the wild, and the job that they're going to give you is not like do any of those 5 things. No, it's like you're going to design and build the entire house. That's basically the analogy for our software development world. They throw you into the wild and you're just expected to be able to do the whole thing. So we go and look for guidance. We go and look for a way to basically succeed in this immense task that we are giving. So we go to conferences like this one. And we listen to people speak, like you're doing just now. And you go on the internet and you find blog posts and stuff like that, and you try and learn more and you educate yourself. And most importantly, you look at what the big players are doing. What architectures are they using? What models are they using? And you try and adapt that to your situation, and you try to apply these things. That's very normal. And very often we look at the most experienced developer in our team because that's a guy that we can learn a lot from. So we do as these people do until we run into the wall. Does that look familiar? That's me on a software project. Tried to make it, didn't quite. So why does that happen? Why do we run into that wall? That's what we're going to try and find out today. I'm going to tell you 6 stories about Chad. Now, Chad is kind of like an asshole. Chad was always on my team. And if you notice any resemblance to any real people, that is merely coincidental, okay? So he's not a real person. I'm going to tell you 6 stories, and at the end we're going to wrap things up, see where we go. Now, the first story I want to talk to you about is a story about RavenDB. I was on a team with Chad, and he was given a task that involved doing this. We had a system that was parsing text files. Pretty simple. And at the moment that we were building this thing, we already used about 70% of the data that was in those text files. But our manager came to us and was like, yeah, that other 30%, that could still be relevant in the future. So we might want to store that somewhere so that if in the future we want to reparse all the history, we could still do that. So this was the task that was given to Chad. And at the time, Chad was really, really passionate about document databases, and he had just learned about RavenDB. And it's like, okay, we're going to put that data into RavenDB. We're just going to parse the entire text file, put it into RavenDB, and store it there. Now, what went wrong is that the price per gigabyte of a database like RavenDB is pretty high, even if you run it on your own infrastructure, because you have licensing costs and stuff like that. And you have to maintain the underlying operating system and maintain the database engine and patch everything and so on. And it took a long time to write this. And not only that, every time there was a little change in the file format, it completely broke because we were actually parsing those text files before they went into RavenDB. So we ask ourselves, like, what did Chad forget to consider? If you find a solution to a problem, you should first make sure that your solution is a technical fit for the task that is at hand. Are you choosing the suitable technology to actually solve the thing that you're trying to solve? And the questions that can help you with this, so that you're not trying to put the square peg into the round hole and have to end up opening the lid, are these questions. It's like, does this help with our problem? How does it compare to competing technologies? Is there maybe something out there that is more suitable, that will help us more? Is it simple enough? Is this like overcomplicating things? What is the cost of the solution that we're choosing? And stuff like that. Now, Chad went wrong here because he chose a wrong solution. He chose a database. But if you only use a database to just store data for possible future usage, it's very expensive because databases have indexes and redundancy and all that sort of stuff built into the engine. It's optimized for query performance, but you're not using the query side. All of that, it was not a really good fit. So a much simpler thing to do would have been to just dump the text files into something like Azure Blob Storage or Amazon S3. Because those solutions come at a much lower cost, and it didn't require us to parse any of the files. They are very robust because somebody else makes them very robust for us. And you can very easily make them redundant as well. And you don't have to care about the underlying operating system and whatever. You can just dump your files in there. So if Chad would have stopped for a second to consider the technical fit, he wouldn't have gone with RavenDB. But we learned the hard way. We ended up writing RavenDB back out of the solution. But yeah, that was what we learned from this story. Now fast forward a couple of months, and we are faced with a problem that we had to solve for another team. Basically, what we had was a solution that was built by a bunch of contractors offshore that was thrown back at us. And basically, all of the code was intertwined. We had presentation logic, business logic, data access, everything was in the same files. It was all causing too many problems. They called us in because they had a question about the menu being slow. Now, we found out that there was not just an n+1 select in the menu, there was like an n times n+1 select in the menu, which made it horribly slow. Now, what we wanted to do is separate between presentation and the rest of the logic. I mean, that was like the first boundary that we wanted to introduce to make sure that we could get rid of those n+1 selects and like get a point of reference for performance. So Chad came to me and he suggested Agatha. Now, this was 2014, and remember 2014 because this becomes relevant in a moment. Chad had just suggested this to me. Now, if you're not familiar with the framework, it doesn't really matter. What it does a request response pattern that you can integrate in a solution. You can use it over WCF if you want to, but you can also use it in process, which is really cool. And it actually solved our issue because we could run it in process and we could make a separation between the presentation logic, the views and the controllers, and the business logic that was going to live in the Agatha handlers. And Chad had used this before, so we had some experience, so this was a really, really good idea. So it was definitely a technical fit. But you can already feel that something went wrong. And what went wrong is that Davey Bryan, the guy who wrote Agatha and maintained it and was pretty much the sole maintainer, disappeared off the face of the earth. And he had already stopped maintaining it in 2013. But that's just the thing that Chad forgot to check before he implemented it into our solution. And all of a sudden, we had this perfect technical fit that was solving our problem that became a liability to our project. Because that was also the time that a lot of stuff was moving in the Microsoft ecosystem with async await, but Agatha never got support for that because it wasn't actually being maintained. So that's the second thing that we have to remember is if we are actually choosing technologies, there are certain warning signs that you're going to want to look out for. Certain technologies can become a risk. For instance, you have to worry about who is maintaining this. Is this like their core business? Is this a side project for them? Is there maybe more than one maintainer? That could be an important thing. Also, something you might want to check, if a company has just been taken over, that's like the moment that licensing models change. And that stuff starts costing way more money than it did before. And also, you have to have a plan B. If it's open source, you might want to maintain your own fork if it's really going to be something that is critical to your operation. But all that stuff you have to really worry about. If you use open source stuff, if you use public NuGet packages, it's not a bad idea to check what the people who are maintaining them are actually doing. Are they still on board with this mission? Now, what could Chad have done is used Mediator, which does basically the same thing. It's very, very similar. It's open source, it's under the Apache license, so if at some point you would want to maintain your own copy of it, that would be fine. And it's very actively maintained by not just one, but more than one person. So that would have been a great plan instead. Now we learned about technical fit and warning signs, so we're not going to make those mistakes over and over and over again. Fast forward 2 years later, Chad and I are on another project. And this is a project that had been developed for a long time. There was about 8 man-decades of code into the code base. But it was pretty okay. I mean, the state of the code was good. It was proper, solid dependency injection. It had an event bus that talked to some other software projects. And all the data was stored in SQL Server. Now, we were faced with a page where we wanted to keep an audit log of what had happened with the data that was presented on that screen. And that is something we had never done before. And this was around the time that Chad had become a huge fan of Greg Young, who actually founded this conference. He became a big fan of Greg Young and of all the philosophy behind event sourcing. And he suggested that we used Event Store. It would actually be perfect for something like an audit log and presenting the data like that. And it was very actively maintained. Weren't any real warning signs. It was a technical fit, so Chad went along with it. And he started implementing Event Store inside the code base of that product to build that screen that had the audit log. But it still went wrong. Otherwise, I wouldn't be telling you this story. Now, in our team, we had mainly junior developers and some overseas contractors as well. And nobody on the team, except for Chad, had any knowledge about Event Store. So what ended up happening is that whenever something needed to be done in one of those screens, and it started with the one screen, but of course there came others, nobody on the team wanted to touch it except for Chad. And that became a bit of a problem because as more and more screens adopted this functionality, I mean, this started really hurting us. And Chad became like a single point of failure inside our team. So what we forgot there is that if we are using something and we start using it more, we should get the whole team up to speed on it. And it's not just a matter of just giving a short presentation, it's like being actively involved in writing code that uses this project. So that's the stuff you have to worry about. Like, do we already have the skills? If not, is the knowledge available? Is there documentation? Are there courses we can follow? Maybe conferences we can go to? Do we have access to people who build it? I mean, whatever we need to do to make sure that not just one person can work on this, but preferably a large part of the team. So what Chad could have easily done is, instead of just like developing everything on an island and applying his awesome skills to build the screen, he could have actually spent time on teaching the rest of the team and gotten some other developers involved, maybe pair a little bit with them, maybe write some documentation on how this stuff worked. And that could have helped like others take their first steps and overcome this problem of team skills. So if we have those three things, we check that the thing we're actually going to use is a fit for our problem, and we have no warning signs, and we make sure that we get everything, we get the whole team on board, we're not going to have any more problems, right? So this next story is about an ORM which I dearly love and hate at the same time. For those who are not in the Microsoft ecosystem, Entity Framework is the object relational mapper of choice if you're doing anything in .NET. And what happened is Chad came up to me, he took me aside and he said, "Hannes, we have to stop using Entity Framework." I was like, okay, so tell me more. And the things that he told me about, like, okay, Entity Framework is slow. Wow, this is like the wrong text on the slide. He told me, like, ignore the left side. He told me Entity Framework is slow, it puts out really bad queries, it's very hard to tune stuff and all stuff like that. And it would be a lot better if we wrote our own SQL. And I don't really necessarily disagree with all those points, except for the application that we were building was mainly a CRUD application. So an object relational mapper in that case would be a very, very good fit to the problem. So I wanted to understand where his reasons came from. So I sat down with him and we figured out like his frustrations. And the first thing is like whenever I start something up, it takes a really long time to respond. It's like, can you show me? Because I don't have that experience with Entity Framework. So he fires up his debugger and he shows me the first request, and the first request comes back really slowly. But for those of you who have worked with this, the first time that entity framework does anything with a DB context. It has to build its mental model of how things are pieced together. What do the entities look like in code? What do your tables look like in the database? What is the mapping between those things? That has to be built up. And that is a hit that you're only going to take on the first ever DB context of that type that you initialize. But because you restart your debugger whenever you're developing stuff, that means that you're going to hit that way more than your user will. You're going to hit that every time that you hit run in your IDE. And that was what he was frustrated with. It's like, do the request again. Oh, now it's fast. Maybe the database cached something. It's like, no, this is just your DB context behaving the way that it always behaves. And there were a couple of N+1 selects in this code as well. So we fired up a database profiler to see what queries were actually executed on the database. And we found some N+1 selects. We found the place in the code where it went wrong. And I explained to him how eager loading worked to actually fetch those entities in one go. And it solved this entire performance problem in that place. There was one query that had a missing database index. The query itself was fine. But there was an index missing in the database on a very large table, which hurt performance there. And then there was one table that was very, very wide. It had lots of columns, and he actually fetched the entire entity, and he only needed 3. So after we went all through this, a lot of things clicked for Chad. He understood, like, okay, I've been using this wrong the whole time. I just didn't understand. So the problem was, up until that day, entity framework was magic for Chad. It was a black box that you put queries in and stuff came out, but he didn't really understand what was happening behind the scenes. And this is something I always tell the people I work with that we should be doing as a team. It's like, take away the magic of the stuff that we're using. I'm not saying you have to build everything yourself. No. But you have to ask yourself, how does this work? What did the people who built this thing need to succeed in building this library, framework, whatever? Because if you know which concepts they applied and what tools they have used, you're a lot less likely to use this library in the wrong way. It will also help you understand the effect of the way that you're using this thing on everything that is underneath the surface. And there's a couple of ways you can do this. You can prototype like 1 or 2 features and see if you can maybe get close to building 1 or 2 features quick and dirty to understand what technology goes behind it. You can go and look at the source code if it's something open source. I mean, there's a lot of things you can do to start and understand what goes in it. And if stuff seems like magic to you, that's usually a recipe for disaster because you're so likely to use it in the wrong way. So Chad learned, and we went to another project. And this was a very, very, very old code base. It also had lots of years of work into it. But Chad had grown so much as a person. He was really the superhero on the team. I mean, he went to conferences, he read blog posts, he was always like finding better ways to do the things that we were doing. And whenever he found something that could be done in a better way, he would always teach the rest of the team. So if he was sure that it was a technical fit and there were no warning signs, and he would actually get the whole team up to speed and explain it to everyone. And that was really cool. He really carried the team in lots of regards. But after a while, you already get the team, right? Stuff still got wrong. Chad did learn, and he did explain it to everyone. And the whole team followed his lead, so it's not that they didn't understand. But the problem that we had is that the old code remained the old way. Much like a tree trunk, you could take a particular piece of code, look at what the technologies were that were used, and kind of date it. It's like this was probably built in fall 2015. Because the front-end framework was Angular, and then the back-end they were doing solid, but no dependency injection. And you could figure it out. And what we had was a code base, and now I have to read my notes here, that had 4 different front-end frameworks or libraries, 3 different programming structuring codes in the back-end, 2 different API frameworks, 2 database engines, and 3 different DI containers. So that's the code base we had, and it was absolute hell. And you can already imagine if you have to bring a new developer up to speed in that project, it's gonna take months. Because whatever task they pick up, they are encountering something new. And the people who have been there for a long time, they go, oh yeah, that's okay, no, we used that back in the day, you should look there. And it became really, really hard to onboard new people in that team. So this is something you should always think about. When you bring in new stuff, think about if there is any old stuff that you want to throw out. Does this replace something you already had? And it is really not optional to factor in the cost of writing out the old part to replace it with the new. And that's something that you should really present to your business. And if you cannot make a business case for replacing the old with the new, because there is something that you're actually going to benefit from, maybe that replacement is not what you need right now. Maybe you're just being the magpie that is looking at the shiny thing that you want to put on your resume, but is not bringing the team any value. Because having the 2 side by side is actually a long-term cost that is far greater than we as developers usually anticipate. So the questions that you're going to ask yourself is, what are we actually trying to solve by bringing this new thing in? And do we really need it? And what can we replace? And what is the effect on maintenance and onboarding and all that kind of stuff? And what you really should do is hollow out that tree trunk. You migrate over the old code to your new frameworks and make sure that at some point, and it doesn't have to be right away, doesn't have to be the only effort you do, but if you want to move your front end from one framework to the next, you should not bring in a third before the first migration has actually taken place completely. And that's something that we both learned at that project. And since we both got more awesome as we moved on, we came to a new greenfield thing. And this was the chance to really do what we wanted to do. I mean, there were no pre-existing conditions that were going to hurt us. We could do whatever we wanted. So Chad got to designing an architecture for this thing, right? So he came up with all the new buzzwords that were relevant at the time. He's like, we're going to do the front end in Angular. We're going to use identity server for authentication. We're going to run it on Docker and Kubernetes. We're going to do everything microservices. And for storage, we're going to do MongoDB because document bases are just better. But the team had no experience with any of this. Now, we already talked about this. That is a huge team skill violation, right? The team got stuck on learning this new stack. It was too much to handle for some of them. Because we were doing everything in microservices, stuff was becoming very hard to debug. It was becoming hard to deploy. People were struggling with so many things. And what seemed easy at first, working with a document database, turned out to be more daunting for most people than Chad had anticipated. And because of that, what was supposed to be a very simple line of business application, and you can already feel that microservice is not the best fit for a small line of business application, that project got a huge delay. We have this massive team skills violation, and this is something that I want to reflect on now instead of earlier. Because we're developers and we are always learning new things, it is always risky if you combine the learning of something new with a deadline to deliver something of value to your business. Because those two will always conflict. You're always going to struggle more than you first thought. There's always going to be more time spent into it. So whenever you try and learn something new on a project, which happens, budget extra time for it. Maybe build a prototype, do a team learning session, maybe mop some of it. But all of that is maybe going to take a little bit more time. And make sure that you explain this risk to the business. And I know that we developers don't like doing that. We don't like oversight about the technical stuff that we're doing because the business doesn't understand. But it's a really, really good reality check. If you can explain the value to a business owner of doing this thing that you want to do, that means you immediately have a case for it. Don't ever tell this lie. If the business asks you, why are you doing this? Oh, we're just going to do it so we can deliver more and of higher quality. I mean, this is just an awesome new thing. It's almost never true because it always needs a ramp-up time. Maybe after a while it will help you, but in the beginning, it's almost never the case. So the thing that Chad forgot there is he took a lot of issues that he had in the past and over-engineered this line of business application. And he put down an architecture that would be fit for something really large with a lot of teams working on it, but wasn't really fit for a single team pushing out a simple CRUD application. The motto that I always go by is that your architecture should support you and it should help with the problems that you have. It should never be the cause of your problems. If you're doing that, you're doing it wrong. Does that mean that you don't do any design at all? No. You still have to have a vision about what you're trying to do and how you're going to structure things, but just don't complicate things. Keep it simple. Start with the simplest solution to your current problems and for the foreseeable future that you can think about. And then push it out. Because I've always felt that if you release something to users, that's when you learn the most. You learn how the users respond to it, how your systems behave. If you have proper monitoring, you see what errors you're getting or where the load is situated. All that sort of stuff is very, very hard to learn in a cubicle of a developer sitting somewhere just writing code. Learn what causes you pain and solve that. That's the model that I use with architecture. So have enough of a design to deliver a bit of value and then iterate on it. And if we would all grow to the size of Netflix or Spotify, we would probably end up with some form of microservices anyway. But if you look at microservices, and I know this is maybe a bit controversial, but there are only 4 real technical reasons that you would actually need them. You would need them if you need to scale stuff independently. So if there are certain components of your entire system that you need to scale independently, you can only do that if they are in a separate service. If you need to support different features for different clients, that could be a good reason to do microservices because then you can swap out those parts of the system. If you require different technology stacks to build different parts of your bigger system, that's also a very good reason to swap to microservices. And if you have conflicting dependencies, because most programming languages don't allow you to include 2 versions of the same package. Everything else is just want. Now, microservices solve a problem that you will probably hit at a certain scale. It's almost never what you hit with a simple line of business application. And I know that we all look at those big players. I told you that in the beginning. But a lot of us are not writing software for those players. A lot of us are writing software for local businesses and we're solving a different scale of problems. And you have to be tall enough to actually reap the benefits of doing that. So what Chad could have done is learned one of those things at a time. He could have just written the application and learned one of those 5 things. Maybe do the front end in Angular, but still deploy it as a monolith and still write your backend in ASP.NET and still use SQL Server. Don't do microservices. And you can prepare for future splitting off of certain parts of your system. That's really not that hard to do. If you go and look on BuildStuff's YouTube channel, I did a talk about that, I think in 2018, how you can, in process, still already prepare for the future splitting off of parts of the code. So if you apply proper solid and you prepare for it in vertical slices, it shouldn't be that hard to, in the future, decouple a system. You should at least think in your code which concepts belong together and which don't. But then it doesn't really hurt to have a monolith. You push it out there, you see what people do with it, and you react. Deliver your value. So the 6 stories bring us the 6 lessons. Is first consider if the thing that you're doing is a technical fit for the problem that you're trying to solve. Check if it can become a liability. Check for warning signs. Check if you can get everybody up to speed on what you're actually doing. Take away the magic. Make sure that you understand how it was built so that you're using it in the right time, in the right way. Trim your stack. Hollow out that tree trunk. Make sure that the old stuff gets replaced for real so that you can keep bringing new people on the team. You can get them up to speed so that it doesn't become daunting to learn everything that you're using. And make sure that your architecture follows your problems and doesn't cause them. Now you're probably wondering, who is this Chad for real, right? Well, in some of these stories it was me, or it was the whole team that was showing this hurtful behavior. It might have been somebody else on my team, or I totally made him up to drive home a point. But you may have noticed that I wrote it in all caps, and the reason I wrote it in all caps is because I wanted to make it an acronym. It's the carelessly or helplessly acting developer. He's not doing this on purpose. He's not hurting the team on purpose. Always remember that if you have a Chad on your team. They're almost always trying to help. They're almost always trying to do the right thing and to actually do what we need to do to succeed. It's just important that you recognize which part of the behavior are hurtful and that you try and solve that. But Chad was, in none of these stories, was the bad guy on the team. He just never was. It's just that some of the things he did ended up causing problems. So what I want to do, if you're all on board with this, I would want to become RAD. Do you want to become RAD? Like responsibly acting developers? No? Okay. Then we're done here. But if you want to become a responsibly acting developer, all you have to do is apply some of the things that I told you about in this talk. Now, if you're on board with this, you can spread the word in your team, and it's really easy to do so. You can follow RAD Certification on Twitter. I have a certification program. You can become RAD certified today. So if your manager told you that you needed to get a certificate this year, today is your chance to actually make that happen. You go to radcert.com and you use your favorite identity provider. Answer 10 questions, and if you can show me on your phone that you actually succeeded the quiz, you can pick up this swag from me today. It's a couple of stickers and some coasters and an actual certificate that I will write your name on. Now make sure that this whole thing is a joke, but it exists for real. I have the certificates with me. I'll be out in the hallway after this talk so that the next speaker can prepare. All I want to do is, for all of you, if one of you stops showing this behavior after this talk, I'll be happy. We need to professionalize as an industry, and I'm trying to do my share, and I'm hoping that all of you are on board with that. My name is Hannes. I work for a company in Belgium called Access. That's my Twitter handle and my ICQ number. I'm trying to make ICQ great again. And as Theas told me, I'm the father of 3 kids. I build guitars as a hobby, and I really like Lego. And I also like Akka.net, which is a technology that I'm giving a masterclass about next week. So if you're interested in that, feel free to hit me up in the hallway and I'll explain you all about it. So that was my story for today. I'm not sure if there were any questions in the chat already. No. You have questions? Chad. Oh, Chad. Oh, yeah. Nice. Nice. Questions about Chad? Or in
Anyone
the chat?
needs any advice, maybe? All right. I guess they're gonna jump on you on Thursday before you get to the stage.
Yeah, that'll be fine.
Remember, he's a superstar.
No. I'm just tagging along. But thank you all for coming, and have a great rest of your conference.
Thank you, Hannes.